What's up guys, and welcome back to another video. Sorry that I have been gone for a while now. I was really busy finishing up my master's degree, but that is all done with now, so I'm happy to be back and happy to be able to be making some more videos. So in today's video we will go through the Matplotlib library of Python, and this is a super useful library for all things data visualization in Python. So the video will start off with going through the Matplotlib basics. So as you see on the screen, we'll be creating like line graphs such as the one you see here. You'll learn how to format these lines in different ways. You'll be able to add a title. You'll be able to add labels to your X and Y axes, format your tick marks properly, add a legend, etc. So all the kind of basic Matplotlib things you want to know. Then we'll move into other types of graphs such as bar charts. And we'll finish this video off with going through all sorts of like real world examples where you can kind of combine your data science skills that you might have using like Pandas library. And if you haven't learned anything about the Pandas library, I recommend you watch my video on that. So with that, the kind of the real world examples, we'll do stuff such as like plot the USA versus Canada gas prices off of data that we have that I'll link to in a CSV. We'll do some histogram stuff. We'll do some pie chart stuff, and we will do some box and whiskers chart stuff. I can't get through every type of graph in this one video, but if there's certain things that I didn't cover and you really want me to cover, let me know in the comments. That would be super duper. Yeah, that's all I got to start this video. Let's just jump into it. All right, let's start out by loading in the libraries that we need for this tutorial. So we're gonna import matplotlib as, or .pyplot as plot. We're going to import numpy as np, and we're going to, for the later examples, import pandas as pd and run that. And so if you have all these like already installed, you won't get any errors. If you do get an error when you're trying to run one of these, you probably need to install it. So you can either do a pip install matplotlib, pip install numpy, pip install pandas, or you can install a Python distribution that already has these packages, such as Anaconda. I'll link to how to do this in the description. Okay, so now we have our libraries loaded. Let's now build our basic graph. So I always think it's kind of the hardest part about anything with Python in general is starting with that blank space. So what I recommend for Matplotlib is always start at the documentation. So I have a link for this in the description, but here is the home page of the matplotlib.pyplot documentation. And what I recommend is like whenever we're trying to do something new, just do a Control F and like look for it. So if we look for plot here, that's like we're just trying to get a line graph on the screen. Box plot's not what we want. We don't want it. Event plot. Okay, this looks good. Plot y versus x as lines or markers. So this is what we'll start off by doing. As you can see right here in the examples it gives plot x comma y. So that's the command we'll have to run to make this work. And just to know what x and y are, if we go down to parameters, they tell us that commonly these parameters are 1D arrays. So we know we need to pass in 1D array to the plot function. So if we do plot 1, 2, 3, that's going to be our x, and 2, 4, 6 will be our y. I can't type. And run that. Plot is not defined. So we imported pyplot as plot. So when we run this function, we actually have to do plot.plot, and then this is our x, and the second array is our y. So let's see what happens there. Yay, we get a graph. And to clean this up a little bit, I recommend moving our variables into, or moving our arrays into variables. So x is 1, 2, 3, and y is 2, 4, 6. And we can change now this to x, y. And one thing that's annoying with Matplotlib, if you're doing this in Jupyter Notebook by default, is you have this annoying little line here. So if you want to get rid of that, you can just actually call plot.show. And that's the correct way to actually show this graph. Okay, now that we have just a line on the screen, let's start adding a little bit more to our graph. So to do this, let's go back to our documentation, and go back to just the pie plot. So I think this is a good spot to start because you always can kind of just Control F and find something you're looking for. So let's say we wanted to add a title to our graph. If I type in title, it points me right to a couple different places that I probably want to look at. And right here is what we're looking for. So set a title for the axes, click that. And this tells me all sorts of stuff about how I call this. So it looks like I can just do pieplot.title. So I can do plot.title, and let's just do our first graph. And run that. As you can see, our title is now there. And same thing for a lot of the different parameters. So going back to the documentation, if I want an X label and a Y label, I just type in, I guess I knew that, but let's just say Y label, nothing comes up. Y, or just even label. C label, label a contour plot, that's not us. The fig labels, no. Pi, no. Title, no. X label, Y label, that's how we get there. So you can keep doing this and really easily find what you're looking for. I think it's a good place to go if you kind of if you forget things, because I always forget things with Matplotlib. Okay, so adding a label to X and Y, plot.x label, X axes. And I guess I'm getting really enthusiastic because I keep adding exclamation points to all my stuff. Y axes. Yay. Let's see what happens. Yeah, and I'm gonna just get rid of these exclamations. I don't need them. Okay, so now we have a graph, and we have a title, and we have a y-axis, x-axis. In a real graph, we would label these properly, but for the sake of this example, we're just kind of getting a feel for how we add these. All right, so now that we have our title and labels, one thing we might want to do to them is resize them. So if we look at the documentation for title, one thing you'll notice is that you can pass in this font dictionary. And it gives you a little bit of details about the font dictionary here. But basically, there's all sorts of options that we can do and like play around with our font. So let's say I wanted to change the font of our title. I can do font dict equals, and I can pass in font name. And let's say my good old trusty reliable Comic Sans MS will be our new font. And if you look at that, we got a nice new font on our graph. And if you can't see it, well then, in that case, I'll change the font size to be something like 20. Now you should definitely be able to tell that I've changed the font type. And in the description, I put a link to all of the known Matplotlib fonts that you can use. And if you look through the documentation, you kind of find some different options you can do with this. And you can also do the same thing with the labels. I could do like font dict equals, let's say I wanted to make this font Arial, and that honestly might be the default, but if I did it like Comic Sans as well, you can tell that the x-axis now has changed. But I'm going to let this be for now. Okay, so we did labels. All right, so now one thing that's bothering me is the tick marks. Let's say I just want to do integer numbers, and I'm going to add a couple more values to our graph. So I'm going to go to 5, and we'll start at 0, and y will go from, y is always going to be 2 times x, so it's going to look like that. Oh wow, it magically did it for us in that case. I don't want it to magically do it for us. Okay, let's say we went to 4 and we wanted just the integer values. We didn't want any of the decimal values. So how do we change our ticks? So we can do that by doing plot.xticks, and our xticks will do 0, 0, 1, 2, 3. And I also just remembered this command by using the documentation. And our y ticks will be, how about 0 to 10 every 2. So 0, 2, 4, 6, oh my gosh, 10. As you can see that, now we have the tick marks working properly, and maybe I wanted to add 4 as well. So now we labeled our ticks differently. And one thing that's cool to know is that the graph will automatically resize based on how we set this. So if I set one tick to 1,000, well, now our graph kind of looks like not too good. But it's nice that you can easily do that. 4 is better. And you can do the same thing with Y. Let's say I wanted to make the last one 100. As you can see, it changes up the sizing of the graph. One thing that's also cool though is even if I didn't evenly space these out, if I did like 7 here and then 7.5, as you can see, it properly puts those at the right spot in the graph. I'll leave it like this. I'll leave it a little bit weird, but yeah, that looks good to me. Okay, so we have our first graph. Let's add a legend and make this line a little bit more exciting color-wise. So if we wanted to add a legend, we can do, and I'm going to actually, because I like showing how the documentation is helpful. If I looked up legend, fig legend, that might work. Just this legend, place a legend on the axes. Like by looking up legend, I figured out that the call is just legend, and it gives me some examples. So I always like to refer to this documentation. Okay, so plt.legend. And what happens when I do that? No handles with labels found to put in legend. So it's complaining because we don't have anything to label. What it's saying is, how do we label this line? And the way we do that is by passing in a label to our plot function. So in this case, our x and y, we plotted x to be, or y to be 2 times x. So I'm going to call the label here 2x. And as you can see, we get 2x right there. Okay, let's say now that we wanted to change up the color of this line, maybe make it thicker, do some other things to it. If we go to plot, where's plot? We'll see all sorts of properties that we can do in plot. So what I'm seeing right here is you can pass in all of these different parameters to our plot. And it probably lists off what we can put, maybe not. It's not super specific, but if you look hard enough, yeah, you can see all of these properties that you can pass into the plot function. So one thing we could pass in is color. So if I passed in color equals red, it'll work. And it will know, I think, the common colors. So if I did yellow, if I did like yell, which is not a color, it's going to yell at me. It might even work with Y. Yeah, cool. And we also can pass in hexadecimal colors. So I could do like A, B, A, B, A, B. And we get like a grayish color. This is helpful because you can use like a color picker tool and pick pretty much any color we want here, but we'll stay with red for now. The other parameters I could pass into that, let's see what else we had. I could do, I think, line size equals, let's say 12. Oh, that is not a parameter. Not a parameter either. Go back to my documentation. Size, marker size, maybe that's it. Marker size. Oh, I also see line width here. So line width equals 2. Oh my gosh. Line width equals 12 makes this big line, maybe 2. It's a bit bigger than I think what we had. We can also we can label a marker. So let's say I wanted to add dots into this. As you can see, you can't really see it too well, but maybe if I made the marker size a little bit bigger. And I'm just kind of passing these in so you can kind of see what you can do. Oh, that didn't work. let's say 10. Yeah, as you can see, now you see big dots on our graph. I can also do marker edge color. There's all sorts of properties. I'm just like continually passing these in, but now you see a different type of dot and whatnot. So this is pretty cool that we can have all of this customization. It sometimes takes a little while to get what we want, but it's usually, it's just nice to have this power. And one final thing I'll pass in is line style. So there's all sorts of line styles we can pass in, and you can read all into the different ways you can do this in the documentation. One thing that's pretty cool is that instead of listing all of these keyword arguments, sometimes we just want to make a different type of line quickly. So there's actually a shorthand that you can use to kind of do pretty much the same thing. So if I comment this out real quick, we have no graph. What you can do is there's a shorthand notation that allows you to kind of have a pretty good amount of customization quickly. So the shorthand notation is color, marker, line, style, I guess. So if we go and copy this line from above, let's say we just passed in this. Now what we can do is before we add our label, we can pass in the shorthand notation. So I can do color, we'll say red. I think it just accepts letters. You can look into the documentation, see exactly what it does. Marker, we'll do a dot, and then line, we'll do a dash. So watch what happens when I do this. Gives us a nice line with dots in it. If I do 2 dashes, gives us a dotted line. If I do like a different type of marker, I can pass in like a caret like that. Gives us a line with carets in it. It's kind of cool that you can do this shorthand notation and get different types of lines very easily. Just to follow up on the whole shorthand notation, I'm pulling in the docs for the plot function. It shows all the different markers you can use and the different line styles supported and the different colors supported. So check out the plot documentation to see all that. All right, let's move on to our next thing, and that will be, I guess let's just add another line real quick to our graph. So we have our first line. Let's add line number 2. And this one will make a little bit more interesting. And the thing is, like here we had a very straightforward, like you have X and you have your Y. But this is not always easy to do, especially if you have like a function like sine, where you want to plot it at like a bunch of values, but those values are all like, you know, crazy decimals. So I'm going to show you how you can handle something like that. So this is where we use numpy. So I'm going to call this x2. I'm going to say that x2 equals np.arange 0 to 4, and we'll go by 0.5 as our tick. So if I print out x2 real quick, you see that this gives us a numpy array with 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5. I'll actually make it go to 4.5 so it goes to the same spot as our other graph, because this is exclusive here. So we have that. So that's going to be our x's. And so what I can do here is I can go ahead and plot that, and I'm going to plot the square function for it. So I'm going to pass in x2, and then instead of passing in a y, I'm just going to do x2, and I'm going to do squared. What happens here? So now you see we get x2 squared. It goes a little bit higher than our original axis was set, so I'm going to change up the ticks, or maybe I'll just kind of comment this out and see what happens for our tick marks. Yeah, I'm fine with just leaving the default that it gave us. Looks good to me. And now we have 2 blue colors, so let's make this a different color. Maybe you make it red. We want to give it a label as well, so I'm going to do red, and I'm going to say the label is equal to x squared. And one thing that's cool is that it automatically moved this legend to the top left because the positioning was better now that this goes up to the top right. All right, so we have two lines up there. And from the original image I showed, there's some stuff that's still different. One thing that's kind of cool that you could do is, let's say you had a graph that stopped, but you wanted to kind of show the projection of it in the future. So what I did to show that type of a phenomenon is I did like x2, take the first 4 values here, and we'll plot that. What did I do? Oh, shoot. First 4. Is that what I want? I think that will work. Take the first 4 and plot that. And then for the last values, so from, let's say, 5 or 3 on, or let's make this a little bigger. Make this 6 or 5. Bear with me here. From 4 onward, we'll make it a dashed line. And I had a little bit of overlap because I think it'll look better. You'll see in a sec. 4 dash. We'll make this still the same function, but this time we're going to make it a dashed line. So there you see, and I'm going to actually make this a little bit different. There you see, like, maybe something ended here and then you make it dashed the rest of the way. You could do something like that using the format I just showed. All right, what else do we have? I'll probably clean this code up a little bit. Another thing that I showed in the original graph that I showed when I was introducing this video was a resize. So let's say we wanted to resize our graph. Well, we should do that probably near the top of our graph. So I'm going to go ahead and do resize your graph. I'm going to go ahead and do plot.figure. Pass in fig size, and we're going to say, let's make the dimensions 5 by 3. It's kind of an arbitrary 5 by 3. That will give you kind of the ratio of your x to your y. But to specify how many pixels it is, you're going to want to pass in a second parameter, which is DPI, which basically is pixels per inch. So I recommend using a value of around 300 here. If you do smaller values, you'll have more pixelated graphs. So if you can afford having a bigger image, having a bigger DPI is often nice. So in this case, we have pixels per inch of 300. So this is going to actually be 5 inches by 3 inches. So the total pixels will be 1500 by 900 here in this graph. So now it's much, much bigger. Maybe it's a little bit too big. I'm going to be blocking this graph. So I'm going to make it a little bit smaller. But you get the idea then here. So I'll make it like 2 by 1.5. It's not a good dimensions now though. I mean, just play around with this. The biggest issue I have right now is the graph looks so big because I have my screen super high resolution, or the view is like very up close because I want to make sure you guys can see my code. But yeah, this would be a 1500 by 900 graph. I'm going to, just for the sake of the graph, decrease the DPI and make it more reasonable. The issue, you can't really tell from this image, but if you really zoom into the graph, and maybe if you like printed the graph out, it would look maybe a little bit pixelated with a DPI of 100. So probably try to keep this value higher if possible. And then another thing you want to do is you'll want to save your graph. So to save, we can do plot dot save fig. And we can do, say, mygraph.png. And one thing that's nice too is I could pass in the DPI parameter here as well. So let's say when I actually saved my graph, I wanted it to be bigger, but for the sake of being able to show you guys it in a smaller format, I wanted the 100 above. I can still go ahead and save it with 300 and then kind of solves both of my problems. And so this then mygraph.png will save in the current directory that this Matplotlib tutorial is in. It will save in that the current directory, whatever directory your file Matplotlib tutorial is in. This graph will also save there when we run this. Cool. Now we have that saved. All right, let me clean this up a little bit. And just to note, the reason I did this is because this is exclusive, the 6 here. So when I do 5 onwards, it picks up, this actually ends at 5 because it doesn't include 6. So it actually covers everything here. All right, now that we've shown line graphs a bit, let's go and quickly do bar charts. And after bar charts, I think we're gonna just end this video short and I'll do the real world examples in a video that I'll post next week. I just think this video might get a bit too long if I include everything in just one video. So, all right, so I wanna do bar chart. Okay, so bar charts are pretty straightforward as well. Let's say we had some labels A, B, and C, and some values, let's say 1, 4, and 2. Well, if we wanted to do a bar chart, we could just do plot.bar of labels, comma, values. I probably did that wrong. It's values, comma, labels, and we get not what I was looking for. Okay, let's see. It is actually labels first, then values. A, B, C, cool. So that was pretty straightforward, and I can do the plot.show. We can do all of the adding of titles and whatnot the same way as before in the line graph example. Let's skip over that for now. We could also resize it, let's say. So I could do plot.figure, fig size equals, let's say 6 by 4. It's going to use whatever the default DPI is. And then one thing that's cool that you can do with bar charts is you could add different patterns to these. So to do that, and you can really play around with the documentation, do all sorts of different things. I just am kind of following the graphs that I was showing in the intro of my video, so I wanted to just show kind of what different hatch values look like. So I can make the first one have, I'm going to say bars equal plot.bars. There we go. Now I do bars 0, set hatch. That's going to give me the lines that you see down here. I can do the same thing with the second value. Let's make this circles, and you can find all the hatch values in the documentation as well. Let's do the third value. We'll do stars. So now you get kind of a cool little bar chart. I could also add a legend to this very easily. And this will tell me right away that we have A, B, and C, but I mean, they're labeled right here, so legend's probably not necessary in this case. All right. Let's see, what else did I want to do with this? And then if you wanted to make this a little bit neater, if you had like many more, it might get tiring to do this. So you could do something like patterns equals slash O and star. And you could do, instead of this notation, you could do for bar and bars, bar dot set hatch. Guess we want an index as well. We'll just do actually patterns dot pop first item off. So this will get us our right one for each one. It should. Yeah, look at that. If I did pop regular, I think it would take off the last, so this will be stars instead of, yep, look at that. Yeah, so basically what it did is it just popped off the first item for the first bar, popped off the second item for the second bar, and then popped off the final item for the third bar, as you can see there. So that's bar charts really quickly. I think I'm going to end this video here. The real world examples video will be very, very useful, and I'll post that next week. I just don't want to like make this video too long. Let me know your feedback. Hopefully this helped you a bit. I'm happy to be back, happy to be making videos. Just was trying to ease back into it with this. If you enjoyed this video, make sure to throw it a big thumbs up, and subscribe if you don't mind. Yeah, but yeah, look out for the real world examples video I'll be posting in the near future, and let me know if you want to see anything else related to this library after that. All right, thanks guys for watching, and peace out.